If you've ever walked out of a 0625 practical exam feeling absolutely confident, only to see your grade drop because of tiny, frustrating mistakes in measuring length, time, volume, or density, well, this explainer is built exactly for you. We are going to completely rewire how you look at exam questions, turning you from a standard student into a Cambridge examiner. Let's dive straight into exactly how to extract maximum marks without losing points to those simple, painful errors. Look closely at this really common student answer. I measured the volume using a cylinder and wrote down the number. Can you spot the fatal flaw here? The mistake that absolutely guarantees 0 marks. You see, ordinary revision usually fails because it teaches you the physics, but it totally forgets to teach you the language of the mark scheme. The student who wrote this, they definitely know how to do the experiment in the lab, but they haven't given the examiner a single, technical reason to actually award a mark. And this right here brilliantly illustrates the difference between just doing physics and answering exactly the way a Cambridge examiner demands. On the left, we've got our vague 0-mark attempt, but on the right, we have a top-band mark magnet answer. Read measuring cylinder at eye level to the bottom of the meniscus, recording units. Do you see that massive shift? We just went from a passive observation to a precise, actionable scientific method. It tells the examiner you understand parallax error because you mentioned eye level. It shows you understand liquid behavior with the word meniscus, and it proves you understand data collection by stating recording units. Vague explanations are exactly where grade boundaries slip right through your fingers. You might know the physics inside and out, but if your answers lack that technical precision, you are literally leaving points on the table. Now, in a moment, I'll show you the exact examiner clue that changes your answer completely. But first, you need the framework that makes that clue obvious. Okay, so here is the 4-step framework you absolutely must memorize to structure top-end answers for any measurement question. Step 1, identify the concept. Are we measuring volume, time, or density? Step 2, state your evidence or data. What specific apparatus are you using to capture this? Step 3, provide the scientific reasoning. Why are you doing it this exact way? To avoid parallax error? To ensure thermal equilibrium? And step 4, apply examiner wording. Use precise terms like meniscus, anomaly, or precision. When you build your answers through these 4 steps, you mathematically eliminate the chance of missing a method mark. Let's put this into practice. Pause for a second and look at this mock data table. Challenge yourself. Pretend you're the Cambridge examiner holding a red pen. Can you spot the glaring issues here? Look at the numbers. Trial 1 is 12.5. Trial 2 is just 12. Trial 4 is 12.63. We have totally inconsistent significant figures. And look at trial 3, 45.2 seconds. That is a massive anomaly that's going to completely skew any average you try to calculate. Plus, imagine if the header didn't explicitly state the unit, S for seconds. You'd lose a mark for every single missing unit in those rows. The absolute crucial point here is consistency. Every single measurement must have the exact same level of precision and strictly include the correct units. If your timer gives you 2 decimal places, then every single entry in that column needs 2 decimal places. If it's a whole number, you write 0.00. Doing this tells the examiner that you truly understand the resolution of the measuring apparatus you're holding. Now, how does this build into your actual calculations? Well, one of the most common mistakes students make is rounding their numbers way too early. Let's say you're calculating the volume of a block so you can figure out its density later. If you round off that volume to one significant figure before plugging it into the density equation, you have just completely ruined the accuracy of your final result. Keep those intermediate values exact in your calculator and only ever round to the appropriate significant figures at the very final step. And speaking of accuracy, look at how Cambridge actually frames it. Their source specifically warns about substituting equipment. Imagine your lab doesn't have an automatic light gate timer, so your teacher tells you to use a manual stopwatch instead. You must evaluate how this substitution lowers the overall accuracy of your time measurement. Why? Well, because human reaction time introduces a massive systematic uncertainty that an automatic timer simply doesn't have. Recognizing that specific limitation is exactly how you score top marks in evaluation questions. Okay, let's escalate things to a harder challenge. Securing full method marks on practical safety setups and risk assessments. Students notoriously lose super easy marks here because they brush off safety as just, common sense, instead of treating it as a rigorous scientific protocol. Look at this quote directly from the Cambridge Teacher Guidelines. It proves that safety isn't just an afterthought. It is a core, accessible skill. If the examiner asks you for a safety precaution, writing "be safe" or "be careful" is the absolute fastest way to get 0 marks. You have to start thinking like a hazard control expert. Check out the difference here. The flawed answer gets no marks. Be careful with the hot liquid. It tells the examiner absolutely nothing. Now look at the improved top band answer. Set hot liquids in a safe position to avoid knocks and handle with caution to prevent burns. This brilliantly illustrates the exact formula you need to use. Name the specific hazard, state the exact preventative action, and describe the physical consequence you are actively avoiding. You really want to memorize this specific list of safety protocols directly from the Cambridge workbook. If you're doing a mechanics experiment with heavy masses, don't just say, "be safe." Write down, "wear closed-toe shoes to protect feet from dropped weights." Doing an optics experiment? Specify, "use eye protection to avoid retinal damage from lasers." Vaguely writing "be careful" will never, ever pull marks from the examiner. You have to be hyper-specific to the actual apparatus sitting in front of you. Let's see how this safety framework applies to electrical practicals. Following these exact steps prevents large currents from causing burns, shocks, or damaging those really sensitive meters. But here's a pro tip. Turning the power off between readings isn't just about safety. It actually stops the wires from heating up. Hot wires change their resistance, which would absolutely ruin the reliability of your data. So that is a dual-purpose mark magnet. Let's move to the final piece of the puzzle, evaluating your investigation data to avoid the trap of unsupported conclusions. Imagine you've done the experiment perfectly. You stayed safe, you recorded your data beautifully. But if your final conclusion claims a directly proportional relationship when your graph actually shows a curve, you're going to lose those final evaluation marks right at the finish line. So before you finish any practical exam question, run your answer through this ultimate mark magnet checklist to make sure you haven't left any points on the table. Check your graph scales. Do they take up at least half the page? Did you exclude that crazy 45.2-second anomaly from your average calculation? Are your practical improvements really specific, like use a fiducial marker to pinpoint the exact center of oscillation, rather than just saying, "do it better next time"? This checklist is quite literally your ultimate defense against losing marks. Take this methodology and immediately apply it to your next set of past papers, constantly asking yourself if you are truly answering like an examiner. But here is the critical issue. Mastering measurement and data collection is only half the battle. You are still totally vulnerable to the toughest evaluation and graph analysis questions, the ones that catch out 90% of students. Ask yourself, are you truly answering like an examiner or just hoping for the best? You need to speed run that next skill to completely bulletproof your grade. More mark magnets are waiting for you in our next explainer. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. See you there.